Okay. This is what I'd like you to do. I have a graph up here with points A and B. I would like you in your notes to draw 3 different continuous and differentiable graphs that go through those 2 points. Continuous means what? No holes, no asymptotes, no breaks. Differential means no corners. All right, I'll give you about 30 seconds to draw 3 graphs that go through those 2 points, 3 different graphs. Okay, now what I'd like you to do is look at everyone's graph at your table and talk about what is similar with everyone's graph. What is one similarity?
All of them. Even if they won't choose space. And I think that's and you're supposed to stop doing that or all of the 5 and 6-year-olds.
Okay. As I walked around, I saw some people's graphs and I drew some up here. Part 2, what did you talk about with all these graphs? They're polynomials? Is this one a polynomial?
Oh, that's a well, that could be a sine.
That could be sine or cosine. So yours were all polynomials. Okay? But it is possible to have a non-polynomial one up there. Okay? Part 4, what did you talk about? You didn't talk about anything that whole time. Okay? 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 Is that all you have? Okay, Larry, then help them out.
We all cross the y-axis.
Okay? That is true. I like it. Part 3.
Exactly. You go through all the x coordinates between you.
Okay, so since it's continuous, we have to go through all of the x's in between. Okay? Part 5.
Oh, they take all varieties.
versus. Oh, they all have maxes and mins, Miss Homer.
Does that middle graph have a max to you?
It doesn't
Oh,
really.
Larry.
Can we do
Fine, a max for them.
Well, you can have a straight line, can't you?
Yes.
There you go.
What's true about all of the points that I highlighted?
Should a straight line have a max to you?
What is true about the points that I highlighted? Their derivative is 0. So some of you are like, well, couldn't you have a straight line? What's the derivative at any point on that straight line? 0. Okay, so what I was hoping that you might notice is that we have these points where our derivative is 0. No matter what kind of graph we draw, we're going to have at least one spot, if not more, where our derivative is 0. That is Rolle's theorem. Go ahead and write it down and then we'll talk through it. So first of all, our graph has to be continuous or differentiable. If it is not continuous and differentiable on that interval, we cannot use this. Okay? As long as we're continuous and differentiable, then if our A and B values have the same function value, which means if those 2 points are at the same height, like they were on our picture on the previous slide, then there has to be at least one point in between A and B where the derivative is 0. Okay? And that's what we illustrated with all the pictures that we drew on our paper. Okay? So as long as we're continuous and differentiable, our function heights are the same, then we know at least once there will be a point where the derivative is 0. So, in the next example, we are going to find where that is. Okay? How? I'll show you. Okay? So we have the function x squared minus 2x, and we have the interval -1 to 3, and we want to figure out where the derivative is 0 on that interval. Okay. So the first thing we have to consider is our function continuous on the open or the closed interval and differentiable on the open? Is this polynomial continuous? Is this polynomial differentiable? Excellent. Then we can think about using Rolle's theorem. Okay? Before we can use Rolle's theorem, we have to make sure that these x values have the same height. All right? How will we do that? What? Plug them in. All right? F of -1 is what? 3? F of 3 is 3. Since these are the same, then Rolle's theorem can apply. there is going to be an x value between -1 and 3 where our derivative is 0. Do we have the capabilities to find that x value? Okay. Cole, what's our derivative?
Our derivative is 2x minus 2.
And when we set that equal to 0, what do we get? We get x is 1. Okay. We wanted to show that there would be a value between -1 and 3 where the derivative would be 0. Okay. That value is 1. We're continuous and differentiable. Our x values have the same function values. So in between there has to be a point where the derivative is 0. Could there be more than one? Definitely. It's okay to only have one, though. Let's talk about this one. F of x is x to the 2/3 minus 1, and our interval is -8 to 8. What's the first thing that we have to consider? It should be an and, continuous and differentiable. Are we continuous from -8 to 8? Are we differentiable from -8 to 8?
Yes. Just square it, and there has to be a positive one.
What is the derivative?
Oh,
And what's the issue with 2/3 x to the -1/3? X can't be 0, okay? We can't have a 0 in the denominator of our derivative, otherwise it's undefined. So, this is actually not differentiable at x is 0, so we cannot use Rolle's theorem.
So then you're done.
Correct. You like that? If it's not continuous, if it's not differentiable, can't do it. It's not guaranteed that way. I'll have you go ahead and do this one for me. Dina, are we continuous and differentiable? Yes, it's polynomial, so those are easy to think of. Okay? Madison, what is the function value for -2? And what about for +2? Excellent. So Rolle's theorem is going to apply. So Sammy, what'd you get for your derivative?
4x squared minus 4x.
And so what are the values that make our derivative 0?
I got 0 and positive.
Thumbs up or thumbs down, do you agree with Sammy's values?
Yeah, sure.
Yes or no?
Yes.
Okay. Excellent. Now, Rolle's theorem is actually a special version of the mean value theorem. And that's the bigger idea that we're going to work on today. Okay, the MVT up on my board, mean value theorem. That was my shortcut. Okay. So this is the mean value theorem. What I'll let you do is write it down, and then when you're done writing it down, we can talk through it and try to understand what's going on. Okay, so you notice that the first sentence is very similar to Rolle's theorem. We still need to be continuous and we still need to be differentiable. Okay, it does not matter what the function value heights are. Okay, it's okay that they're different. What does this mean right here that I just circled? Close. Slope, we have y minus y over x minus x. Okay, and they just have a's and b's as like their values. Okay, so this right here, this is talking about slope. Okay, the slope between 2 points. Okay, we called that average value when we talked about it back in Unit 2. Okay, so if we find the slope between 2 points, the mean value theorem says that there is going to be at least 1 point between A and B that has that same slope. Okay, the derivative is going to have that same value. Okay, so whatever the slope is between the 2 points, there will be a point that has that same derivative value, that same slope. Okay, that's what the mean value theorem is saying. So go ahead and write this down. F of x equals x squared plus 2x minus 1. And we're going to find the average rate of change from 0 to 1. Okay, so is this a continuous and differentiable function? It is, because it's a polynomial, okay? So those are nice to think about. Now, the average rate of change from 0 to 1 just means we're finding slope from 0 to 1. Okay? So we need f of 1 minus f of 0 over 1 minus 0. What is the function value at 1?
1.
Yep. Minus what's the function value at 0? Negative 1, right? Okay. Over x minus x. Y minus y over x minus x. Our average rate of change is 3. The slope of the secant line is 3. Okay. So now, since we're continuous and differentiable on our interval, the mean value theorem guarantees that somewhere between 0 and 1, this function is going to have a slope of 3. Okay, so let's go ahead and find that. Okay, everyone all together, what is the derivative of f? Okay. Since the slope between 0 and 1 is 3, we want to find where our derivative is 3. Which is at 1/2. Is 1/2 between 0 and 1? Good. Okay. So our C value is 1/2 because the derivative at 1/2 is 3. Slope between 0 and 1. What do you guys think? Is up, up, and middle comes down. Shaken? Okay. Maybe we should do another example.
Yes.
X to the 2/3 on 0 to 1. Larry, did you have a thought?
No.
Okay. Now, we've had a problem kind of like this, correct? Okay. Is f continuous on the closed interval 0 to 1? Is f differentiable on the open interval 0 to 1? Why not, Cole? Okay, so where is the derivative undefined? At 0. The derivative is undefined at 0. Is 0 in this open interval? It is not. So this is okay. We have to be differentiable on the open interval. It doesn't count the endpoints. So this is okay because 0 is not included. What was your question?
Just going back to the previous one where it was x to the 2/3 minus 1. Since that was from -8 to 8, why wouldn't that work?
Because it's not differentiable at 0, and 0 is in between -8 and 8.
Okay.
Okay? Since 0 is not on our open interval, we can do it. Okay? Good question. So, for the mean value theorem, we need the slope between 0 and 1. What is our function value at 1? 1. And our function value at 0? Over x minus x. Okay? So our slope is 1. That's kind of nice, right? Our derivative. Josh, what is it?
2/3 x to -1/3.
Good. So we need to know where is 2/3 x to the -1/3 equal to 1. Which really just means 2/3 equals x to the +1/3, right? We can like divide this over. We know it's not going to be 0 because 0 is not in our interval. So we can divide this over. So x to the 1/3 equals 2/3. Does that make sense? How do we get rid of a 1/3 power? You raise it to the third. Good. 8/27, is that between 0 and 1? Better be, right? So our C value is 8/27 because f prime of 8/27 is 1. Which is the slope between 0 and 1. Okay? Now, there may be a couple times in your homework where you get more than one C value. Make sure that your C value is in your interval. It is possible to have places outside of the interval that have that same slope, but we are only concerned about the ones in the interval. Okay, what I want you to talk about for the next 30 seconds, similarities and differences between Rolle's and mean value theorem.
Well, you were saying
All right, raise your hand if you think that Rolle's theorem came first. Raise your hand if you think the mean value theorem came first. It was actually Rolle's theorem that came first, and then like a century later, Lagrange figured out that we could do, the same concept, but with the slope between the two points. Okay. Essentially, Rolle's is like the special version of the mean value theorem, right? The slope between 2 points that have the same height is 0. Okay, so it's just a special version of it. All right, your homework can be found on your gold sheet. It is not very long. You have only a few minutes left in class, so maybe get organized, write down the information in your notebook if you need to. You need to be doing your homework. Yes, sir.
Which one do you want us to?
Well,
Will it say?
yes, if the function value, it'll say either Rolle's theorem or mean value theorem. Okay. I'll tell you that the mean value theorem will be more prominent. Okay. And really, if you use mean value theorem the whole time, you're gonna, if the slope is 0 between 2 points, you're still gonna be using Rolle's theorem, even if you start with mean value theorem.
174. Then what? 5, 13. Okay. 32.